Isang magandang araw sa inyong lahat. Sa videong ito ay magsasagot tayo ng isang word problem patungkol sa isang vapor compression system na gumagamit ng expander. Basahin muna natin ang kabuuan ng ating problem. A vapor compression refrigeration system using R134A is operated at atmospheric pressure and 1.6 megapascals. The compressor efficiency is 75%. Find the COP if, first, an expander with 70% efficiency is used instead of an expansion valve in the SVCC and the power produced by the expander is not recovered in the system. Also, find the COP if an expander with 70% efficiency is used instead of an expansion valve in the SVCC and the power produced by the expander is recovered in the system. So, malinaw na ang pinapahanap dito ay yung COP ng dalawang cases. Yung una ay yung case wherein the expander work is not recovered at yung pangalawa ay recovered ng expander work. So, iset up muna natin yung formula ng COP para malaman natin yung iba't ibang states na kailangan nating isolve. So, we have COP not recovered is basically equal to the refrigerating capacity divided by the work compressor or the power input in the compressor. So we know that the refrigerating capacity is just equal to the mass flow at the evaporator multiplied to the enthalpy change in the evaporator, which is H1 minus H4 gamit ang notations na nandito sa ating schematic diagram. Of course, this is divided by the power input in the compressor, which is just the mass flow of the refrigerant at the compressor multiplied by H2 minus H1, which is the enthalpy change in the compressor. So, alam natin na yung mass flows ng refrigerant sa evaporator at sa compressor ay parehas lang. So, these two terms will cancel out. So, this requires us to solve H1, H2, and H4. Next, we have the case wherein the expander power this time is recovered. So, this is going to be equal to the refrigerating capacity divided by the net work inputted in the system. So we have the work in the compressor or the power input in the compressor rather minus the magnitude of the power output at the expander. So this gives us M dot E times H1 minus H4 divided by M dot C times the enthalpy change in the compressor, which is H2 minus H1 minus M dot at the expander multiplied by the enthalpy change in the expander, which is H3 minus H4. So, alam natin na itong mass flows na ito ay magkakaparehas lang, so magka-cancel out sila. In other words, the first step in order to solve this problem is for us to solve for the different states H1, H2, H3, and H4. Simulan natin ito sa pagdrawing ng pH diagram. So, alam natin na in your pH diagram, this is your pressure axis and this is your enthalpy axis. Ang lower pressure natin ay atmospheric pressure, which is around 0.101325 megapascals. Samantalang ang pressure ng ating condenser ay 1.6 megapascals. So, state 1 is at the outlet of the evaporator and also at the inlet of the compressor. We know that state 1 is somewhere here because it is saturated liquid. Assuming na nag-undergo ito ng isentropic compression, we know na ang state 2 ay nandito. It follows the isentropic line, but we know that this process doesn't really exist because the compression should be non-isentropic. This is supported by the fact na given ang ating compressor efficiency na 75%. So we know that the actual state 2 is somewhere here by virtue of the second law of thermodynamics. So our actual compression process is somewhere here. Next, we have isobaric heat rejection in the process 2-3. So from here, state 2, pupunta tayo sa state 3, which is saturated liquid. And it will go from 2 to 3 like this. And then process 3 to 4 or 3 to 4S muna is going to be an isentropic expansion. So it looks something like this. So remember that this is an isentropic curve. But we know that this doesn't really exist because we have an expander efficiency that is not equal to 100%. So ang itsura ng ating non-isentropic expansion ay ganito. Finally, we have process 4-1 which is isobaric heat absorption. Matapos ang pagdrawing ng pH diagram, ituloy natin ang ating solution sa pamamagitan ng pag-solve ng ating states. Unahin natin si state 1. Base sa ating pH diagram, ang quality sa state 1 ay equal to 1 because it is saturated vapor, samantalang ang pressure dito ay atmospheric pressure. So, kailangan nating malaman ng enthalpy at state 1 na equal lang sa vapor enthalpy at atmospheric pressure. Samantala, ang entropy naman sa state 1 ay ang vapor entropy at the same pressure. Para makuha ang numerical values nito, tignan lang natin ang ating thermodynamic tables or refrigerant tables. So we have at 0.101325 instead of interpolating here in your saturated table, punta na lang tayo sa superheated table. Merong specific table dedicated for it at makikita natin ang vapor enthalpies and entropies. So H1 is going to be 382.90 while S1 is going to be 1.7476. Kopyahin lang natin ang mga values na ito. Ngayon, tayo ay tumungo sa pag-solve ng state 2S. Alam natin na sa state 2S, ang entropy at this state ay equal lang sa entropy at state 1 which is 1.7476. Alam din natin na ang pressure at state 2S ay equals kay 1.6 megapascals. Ang pinaka-strategy natin sa pag-solve ng problem na to ay una i-identify muna natin ang enthalpy at state 2S at gagamitin natin ang compressor efficiency upang ma-solve ang enthalpy at state 2. So we know that the compressor efficiency is just going to be equal to the ideal work H2S minus H1 over the actual work which is H2 minus H1. In order to get H2S, let us create an interpolation table wherein the constant is at pressure 1.6 megapascal. So we have our entropies here which are in kilojoules per kilogram Kelvin. And we also have our enthalpies here which are in kilojoules per kilogram. So using 1.6 megapascals and this particular enthalpy, kaya nating isolve ang corresponding enthalpy at state 2S. So let us consult our thermodynamic table in order to do so. So at pressure that is equal to 1.6 megapascals, somewhere here, makikita natin na ang entropy na 1.7476 ay nasa pagitan ng dalawang values na ito. So let's just copy these entropies and enthalpies in our interpolation table. Again, we are interpolating at an entropy of 1.7476. So using linear interpolation, kung ano man yung value ng enthalpy dito, ay siyang magiging value ni H2S. So let us just input it in our calculator and do the interpolation. Press menu, go to statistics which is number 6. And then choose two-variable table. So, input lang natin ang values na enthalpies at entropies. Select AC. Type in the entropy 1.7476. Select Option. Press down. Select Regression and select number 5. And then press equals, and there we have our H2S that is equal to 440.8950. Now, if we are going to inspect our compressor efficiency formula, we already know H2S, we already know H1, and eta C is already given, that is equal to 75% or 0.75. We can now just input these values and solve it using our calculator. Going back to our calculator, select menu, press 1 to go back to our original calculator mode, and then input the following values. Now in this case, I'm gonna let H2 be equal to X, para gagamitin na lang natin ang technique na shift solve minus 382.90. So let's press shift, click solve, and then input a certain number that is larger than 440. Sabihin natin nasa 450. Press equals and then press equals once more. We have this value for H2. So it's going to be equal to 460.2267. Okay, so going back to our pH diagram, we already know H1. We already know H2. So let's just solve for H3 and H4. So alam natin na at state 3, according to our pH diagram, ito ay saturated liquid. So the quality at this particular state is going to be equal to 0 and the pressure is 1.6 megapascals. Going back to our refrigerant table, we can see that at P is equal to 1.6 megapascal, the saturated liquid enthalpy is equal to 284.11 and the saturated liquid entropy is 1.2748. So kailangan din natin kunin si entropy dahil ang susunod na process ay involved sa expansion. More specifically, non-isentropic expansion. So let us just copy these two values. Okay, next we have state 4S, and if we are going to inspect our pH diagram, the pressure here is 0.101325 megapascals, and the enthalpy at state 4S is just equal to S3 because this is an isentropic expansion process. In order to proceed, kailangan nating malaman si H4S, at magagawa lang natin ito kung alam natin ang quality at state 4S. So in order to solve for X4S, we need to use the following equation. We have the entropy at 4S, and we know that it is equal to the vapor entropy at that particular state point plus the quality at that state point multiplied by the difference in the gaseous entropy and the liquid entropy. So this S4S is just going to be equal to 1.2748. Whereas these two values can just be obtained using our refrigerant table. So, gamitin natin ang ating refrigerant table. We have at pressure that is equal to 0.101325. At makikita natin dito na ang liquid entropy ay 0.8701 samantala ang vapor entropy ay 1.7476. So, let us just input these values in our equation. Solve natin si X4S using our calculator. Let us just input this equation first. Press Shift, click Solve, and then input a value na nasa pagitan ng 0 at 1 dahil alam natin na ang quality ng isang mixture ay between 0 and 1. So we have X4S that is equal to 0.4612. Samantala, masasolve natin ang enthalpy sa pamamagitan ng sumusunod na equation. We have H4S at alam natin na equal lang ito sa liquid enthalpy at 4S plus the quality at 4S and the difference between the vapor and the liquid enthalpies at 4S. Kakasolve lang natin ang quality. At alam natin na ang values na ito, HF at HG at 4S, ay makukuha using our thermodynamic table. According sa ating thermodynamic table, HG4S is equal to 382.90, samantalang ang HF4S ay 166.07 kilojoules per kilogram. So let us just input these values in our formula. So we already know all the values needed in order to solve for H4S. Nothing is stopping us from inputting it in our calculator in order to finally solve for H4S. There you go. Ang enthalpy at 4S ay equal sa 266.07 kilojoules per kilogram. Kung babalikan natin ang pH diagram, makikita natin na ang process 3-4 ay isang non-isentropic expansion process. Given this, pwede natin gamitin ang isentropic efficiency formula for expander para ma-solve ang state 4. We have eta E, which is the expander efficiency, and it is going to be equal to the actual work in the expander divided by the ideal work in the expander. So we have H3 minus H4 divided by H3 minus H4S. Alam natin ang enthalpy at state 3. Alam din natin ang efficiency ng ating expander. It is just equal to 70% or 0.7. At alam natin ang H4S dahil kakasolve lang natin dito. So using this equation, we can now determine H4. So let us just input the values that we have so far. Finally, we use the functions of our calculator in order to solve for H4. Press Shift, click Solve, and then input a number that is slightly higher than 266. So sabihin natin 270. Press equals and press equals one more time. So we have 271.4834 as the enthalpy at state 4. Going back to the formulas that we derived a while ago, we have COPNR equals H1 minus H4 divided by H2 minus H1. So let us just input the values that we saw for these enthalpies. Let's input it in our calculator. We have 382.90 minus 271.4834 divided by 460.2267 minus 382.9b. We have a COP for the first case that is equal to 1.44. So let us just write it down here. COPNR is equal to around 1.4409. So this is the COP for the first case. Ang COP naman ng pangalawang scenario, kung saan ang expander power ay recovered, ay binibigay ng sumusunod na formula. We have COP recovered that is equal to H1 minus H4 divided by H2 minus H1 minus H3 minus H4. So input lang natin lahat ng values ng enthalpies. So take note na itong dalawang quantity na to ay dapat naka-parenthesis. So let us just input these values in our calculator in order to solve for the COP recovered. So we have the COP for the recovered case that is equal to 1.722. Again, kung mapapansin natin, makikita natin na mas maganda ang performance ng isang vapor compression system using an expander kapag nire-recover natin ang expander power. So that's it. Thank you for watching this video. I hope you learned something, and if you have questions, kindly comment down below.